This video is to teach you how to do goal 1, 2, and 3. The first question, what is the momentum of a 6.25 kilogram bowling ball rolling at 7.5 meters per second? The formula is momentum, which is P, equals mass times velocity. So all you have to do is take your mass of 6.25 and multiply it by 7.5. When we do that, 6.25 times 7.5 turns out to be 46.875, which we can round off to 46.9. And that would be kilograms times meters per second. That is the first answer. The next one, you're supposed to find the momentum of each one, and then rank them from greatest to least. So we're going to keep using that same equation. Momentum is mass times velocity, but we're going to have to do this for each problem. So mass in this case is 22 times 10, which equals 220. The next one is 37 is the mass, times 8, which I'll use a calculator for. So 37 times 8 equals 296. And the last one is a 0.16 kilogram hockey puck traveling at 100. That one you just move the decimal over 2 places to the right. So that equals 16. So if I'm going to rank them from greatest to least, my greatest one would be B, because it's 296. So I'd say B, then the next one is A, which is 220, and the final one would be C, if I rank those from greatest to least momentum. The next problem is I've got a 360,000 kilogram passenger plane moving it down the runway, so that's the same equation. We're trying to find momentum. So 3,600 times 1.5, that's going to be times 1.5 equals 540,000, and the units would be kilograms times meters per second. In the next section, you're just supposed to quantify how changes in mass and velocity affect momentum. So we're working with, the entire time here, momentum equals mass times velocity. So when I ask the question, the momentum of an object depends on the objects, it's going to be these two things. Either its mass and its velocity. If you change one or the other, it's going to change your momentum. The momentum of an object is 0 when the object is at rest. If you have an object at rest, what that means is the velocity is 0. So you're going to plug a 0 in here for the velocity, and you're going to end up with 0 momentum. You can't have 0 mass, because then you wouldn't have an object. So it's really, this one's dependent on the velocity. The momentum of a truck will be greater than the momentum of a mosquito when the truck is, we're going to put the word moving in here. Because even if your truck is at rest, it would have 0 momentum. So even a mosquito would have more momentum than a truck if the mosquito is moving and the truck is not. But the momentum of a truck will be less than the momentum of a mosquito when the truck is at rest. If two objects are moving at the same velocity, then the object with the greater, and it's going to be mass, will have the greater momentum. Because remember, P equals M times V. If they both have the same velocity, the only thing that's going to change the momentum is the mass. So the one with the bigger M, mass, would have the greater momentum. Same idea for number 8. If two objects have the same mass, then the object with the greater velocity will have the greater momentum. So if these are the same, mass is the same, then the velocity is what's going to change momentum. Last question, number 9. How would the momentum of an object change if its mass was cut in half and it was only traveling with half the speed? So what we do is we compare, what if mass and velocity were both 1? We're going to compare everything to that. If that's the case, then the momentum would be 1. So what they want you to do is say, hey, what if you change mass and now it's only cut in half? So instead of 1, we put a half. If it was traveling with half the speed rather than 1, it's traveling at half. So 1/2 times 1/2 equals 1/4. So the way you'd answer this is if the mass and velocity were both cut in half, then the momentum would be 1/4 as much. So momentum is 1/4 as much.